Welcome to the CoSpace Robot family. Today, we'll be introducing you to CoSpaceRobot GP. CoSpaceRobot is an official platform for both RoboCup Junior Rescue Simulation and RoboCup Asia-Pacific CoSpace Challenge. CoSpace Grand Prix is powered by CoSpaceRobot Studio. Apart from the CoSpace programming interface, it provides interface in Scratch, Python, and C. Please visit our website to find out more.
In this session, we will give you a step-by-step guidance to the CoSpace Grand Prix. We hope it will help you to have a better understanding in the CoSpace Grand Prix for beginners and to take part in the CoSpace Grand Prix Challenge FirstSteps category.
Line following is probably the most common application in robotics. It is widely used in industries and even hospitals. If a robot can think, the thought process of a line-following robot will be very similar to that of a human being. And that can be simplified into 3 actions: sense, plan, and act. CoSpaceRobot will give you a unique first-hand programming experience in such applications. Let's take a look at the CoSpace Virtual Robot. It is equipped with one color sensor to sense the floor RGB color, which is a short form for red, green, and blue. One gyro sensor to sense the robot's orientation. One ultrasonic sensor to sense the front obstacles. And 6 infrared IR sensors for line tracking. What is the logic behind the robot's thinking process when it tracks a black line? The 6 IR sensors mounted on the robot are like 6 eyes of the robot. When the first left IR sensor, we call it L1, senses the black line, the robot needs to move forward. When the first right IR sensor, we call it R1, senses the black line, the robot also needs to move forward. When L2 senses the black line, the robot needs to turn left slightly. When R2 senses the black line, the robot needs to turn right slightly. When L3 senses the black line, the robot needs to turn left rapidly. When R3 senses the black line, the robot needs to turn right rapidly. This process repeats forever in a loop, and this will ensure that the robot tracks the black line. Let's code a line tracking program in CoSpaceRobot.
For optimal performance, your PC laptop should meet the minimum configuration. Let's watch a video guide on installation.
Hello, good job. We are almost there. Let's click on the Experience button to see if our computer is compatible with this software. While we are at it, let's also check and see the version of our software. It's always good to have the latest version. Awesome, it seems that our computer is compatible and our software is up to date. And now it's time to activate our software. So there are 3 options: Learn, Compete, and Experience. So for this example, we're going to use FirstSteps. All right, we're going to click on Workshop Pack 1. The activation window has just popped out, so please make sure you're connected to the internet and input your account number as well as your serial code, which is also your license number. So these will be given to you via email, so please make sure to check your email. And also please make sure when you put in your serial code, there are no spaces in the front and at the back, because the serial code is case sensitive.
Double-click CoSpace GP icon on your desktop. Now, choose the level and map, which is also known as the virtual environment. In this tutorial, we will choose Future City for illustration. To adjust the virtual environment, first, click anywhere in the virtual environment. And then, press the Q, W, E, A, S, D keys to adjust the 3D view. If you press Shift plus the keys, it will make the movement faster. If you mess up the environment, you need to click on the Control panel, and then click on Ctrl plus H together to reset the virtual environment to the home position. To manual control the virtual robot, first, click anywhere on the control panel. And then, press the 4 arrow keys to move the virtual robot manually. While the robot is moving, the live sensor data will be shown on the control panel. Double-click on the CoSpace GP icon on the desktop. Now, choose your level and map, which is also known as our virtual environment. For this video we will choose Future City Practice Field. Double-click on the AI button to enter the programming interface. First of all, you will need to create a new project. Click on the New Project button. Please remember to give this program a team ID, a team name, a project name. Remember, once team ID and team name are confirmed, they cannot be changed anymore. However, you can change the project name if you wish. Based on the analysis earlier, we now need to convert the logic into code which the robot can execute. The first statement should tell the robot that when L1 senses the white line, the robot needs to move forward. Step 1. Let's create a statement named L1 senses white line. Step 2. After the statement name is defined, we will add conditions to this statement. We click on L1 until it turns white in color. This means L1 will sense for the white line. Step 3. We should tell the robot what to do when the condition is met. In this scenario, the robot should move forward. That means both wheels should have the same speed. Step 4. Finally, click on Preview button to see whether you have set the correct wheel speed. Great! We have completed our first statement. Repeat the 4 steps above to complete statements 2 to 6. Statement 2. When R1 senses the white line, robot moves forward. This is similar to statement 1. Make sure we have set the same speed for both wheels. Statement 3. When L2 senses the white line, robot turns left slightly. This time, we will set different speeds to the left and right wheels. As the robot turns slightly, the speed difference should be small. Same concept applies to statement 4. This time, the robot turns right slightly. Statement 5. When L3 senses the white line. This means that the robot is almost off track. So the robot needs to turn left quickly. This time, we can set the left motor speed to be negative and keep the right motor speed positive. Same concept applies to statement 6. This time, the robot should turn right quickly. After we have completed our program, we should do a quick check that the logic is correct and make sure every statement has conditions and actions. Once you have completed programming, it is very important to save and build. Save means to save the most recent program that you have just completed. Build means to check syntax errors, create a C code and a dynamic data link file with extension DLL. Now you can click on the preview button to see how the robot will behave. If you wish to modify the program, click on the Stop button and you will go back to the AI panel to modify the program. Now, you can load the program which has been compiled as a DLL file using the Load button in the control panel. After successful loading, we can use the play, pause and stop buttons to control the robot's movement. We can monitor the robot's performance in the control panel. We can also change the viewing perspective from the menu bar. Choosing 𝗖cie_𝗦𝗲𝗏 front camera will let you to have a first-person view, or driver's view. Choosing 𝗖cie_𝗦𝗏 following camera will let you to have a helicopter tracking view. When the robot reaches the finishing line, it stops and the time it took to reach there will be recorded. Well done. You have completed the line tracking program. Let's work on Challenge 1 CoSpace Town. You should launch the Challenge 1 field. The task for Challenge 1 is to program the robot car to travel in the CoSpace Town. The robot car starts its journey from the start station. It must pass through all waypoints before stopping at the destination. To complete the task, the robot needs to track a black line. Let's write a line tracking program. Create a new project. Add the black line tracking program. Build and trial run. This is the sample code for your reference. I am sure that you can make a better program. Why is the line following program not working well for this line tracking task? We have to consider the robot's action at two junctions. First junction is the T junction after waypoint 4. At the T junction, or we say when 4 IR sensors on the extreme right sense the black color line, the robot needs to turn right rapidly. The second junction is the T junction after waypoint 10. At this junction, when 4 IR sensors on the extreme right sense the black color line, the robot also needs to turn right rapidly. This is the same as the robot at the previous T junction. How can we turn 90 degrees right? First of all, we need to specify the speed for both wheels. We set the left wheel to be plus 20, and right wheel to be minus 20. Then, we let the robot run for a certain amount of time without interruption. We call this duration. This can ensure accurate turning. If the duration for turning is too short, the robot will turn less than 90 degrees. If the duration for turning is too long, the robot will turn more than 90 degrees. After a few trials, we have found that 55 seconds is a good turning period for this speed setting. So we set the duration to be 55 seconds. This is the sample code for your reference. I am sure that you can make a better program. Now, let's work on the challenge 2. The task for challenge 2 is to program the robot car to travel towards the finish line. It must pass through all waypoints before stopping at the destination. In challenge 2, the robot has to stay on the black-colored road instead of tracking a black line. Here is the logic for the robot movement. You can use challenge 1 as reference and program the robot. The sample code can be found in the PPT slides. Now, let's work on challenge 3. The task for challenge 3 is to program the robot car to travel towards the finish line. It must pass through all waypoints before stopping at the destination. In challenge 3, the robot needs to turn when it is close to the wall. The robot uses the ultrasonic sensor to measure the distance to the wall and turn away before it hits the wall. This is called obstacle avoidance. The ultrasonic sensor is mounted at the front of the robot. It senses the front obstacles and provides feedback in cm. When the robot moves forward, we can monitor the live feedback data on the control panel. To program the ultrasonic sensor, you have to specify the range of distance as a condition, then set the robot action to be taken when the condition is met. Please write your code for the robot to complete the mission. The sample code can be found in the PPT slides. Well done. You have completed all challenges. Let's move on to the CoSpace Grand Prix Online Challenge. Let's work on the CoSpace Online Challenge, or as we call it, the 𝗖cie𝗬𝗲𝗏 Challenge. Double-click on the CoSpace GP icon on your desktop. First of all, you need to select the correct level. Then select 𝗖cie𝗬𝗏 Challenge tab. Choose the challenge map you will be working on. Analyze the map and complete the code. Save and build. Load the DLL from the control panel. Click on the Start button and monitor the robot's performance. When the robot reaches the finish line or when you click on the Stop button, an ICS file will be created. The ICS files contains the code, result and robot trajectory. Save the ICS file and send it to the event organizer. Congratulations. Well done.
RCAP CoSpace GP Challenge Rules. First Steps category. This category is for absolute beginners aged 12 and below. Welcome to the RoboCup Asia-Pacific RCAP CoSpace Challenge. Automation of routine tasks is currently a concept that interests many industries. Among the most revolutionary parts of it are autonomous vehicles. These are visions of the future of city infrastructure. The main ideas they all share are self-driving cars and shared mobility. Those are set to revolutionize the ways we navigate through cities. In CoSpace GP Challenge, teams are required to build a real robot, develop and program appropriate strategies for both real and virtual autonomous robots to navigate through both real and virtual worlds. For the 𝗖cie𝗦𝗽𝗰𝗲𝗥𝗏 challenge, participants need to program an autonomous car to navigate in a smart city. The autonomous car needs to pass multiple waypoints before reaching its final destination. In this smart city, there are roads, buildings, black and white lines, and waypoints. In the 𝗖cie𝗦𝗽𝗏 challenge, there will only be a virtual robot. The robot has an IR sensor array and an ultrasonic sensor. Students need to utilize the elements in the smart city to plan the best path and program the robot accordingly. Let's take a look at the game process. The duration of the game is 8 minutes. That means the robot has to complete the whole journey within 8 minutes. At the beginning of the game, the virtual robot is placed at the start station. When it travels towards the finish line or end station, the robot must pass all waypoints in any sequence. It does not need to stop at the waypoints. The game ends when the virtual robot arrives at the finish line in the virtual world. If the virtual robot passes all waypoints and reaches the finish line, the team rank is determined by the race time at the finish line in the virtual world. If the virtual robot is not able to pass all waypoints, regardless whether it reaches the finish line or not, the race time for the virtual robot to reach the last waypoint will be recorded. The team rank will be determined based on the number of waypoints passed, followed by the race time.
The detailed rules can be found in RoboCup Asia-Pacific official website. If you are an absolute beginner, CoSpace GP FirstSteps is designed for you. After finishing CoSpace GP FirstSteps, you can move on to study more advanced contents in CoSpace GP-U12 and CoSpace GP-U19. There will be 2 videos in this sharing and highlighted games section, one from 2 of the 3 CoSpace GP series categories.
I'm a game changer. I'm a risk taker. I don't hide from the battle. The battle hides from me.
Hello everybody, my name is nitinRamesh and I am from Singapore doing my primary 4 in 𝗖ście𝗬𝗏𝗏 Primary School. My interest towards robotics started earlier before I got the chance to learn robotics for the past 7 months. This is my first RoboCup challenge that I have participated, and this has given me an opportunity to virtually program the CoSpace robot. I thank the organizing team of the RoboCup Asia-Pacific and my teachers for this opportunity. CoSpaceRobot has given a chance to learn the usage of line tracking sensors, ultrasonic sensors, and motor control. Through the 𝗖cie𝗦𝗽𝗏𝗏 challenge, I have gained the knowledge of programming the autonomous vehicle to follow the track and finish in the fastest possible time. I am most interested in learning from CN2014 As in his challenge, he completed the challenge in the fastest time, taking a lot of shortcuts. I would like to learn from him the algorithms used for the IR sensors and the color sensors. At home, I influenced my sister with my knowledge on robotics and AI. At school, my CCA friends have asked me on the algorithms and I participated in the CoSpace GPU12 FirstSteps. One of the strategy is the broken white line strategy. There were places where there were broken lines and I was curious to test and see if they could help me in some way. So I devised this strategy to move forward when the IR sensors detected no lines. This helped me to shortcut one of the routes, thus helping me to save time. Throughout the challenge, on every obstacle, the robot has to make right turn and only at one junction it has to make a left turn. So I used the timer strategy to get through this barrier. It worked well and I was able to overcome this barrier. There was another strategy was adjusting the speed. There was a time when the robot kept going off the track at the start of the challenge. It was also ineffective when it came to turning at the edges. I decreased the speed and adjusted the turn angle to better suit the route. I would like to present my 𝗖cie𝗬𝗲𝗏 challenge game video. In this, I would like to show the strategies used in my 𝗖cie challenge. When the L1 and the L2 detect the white line, it would go faster. When the robot detects a barrier in front, the ultrasonic sensors detect the barrier and I have programmed it to turn right by default. The IR sensors would then track the line and manage the position of the robot. At this barrier, the robot needs to turn left. For this, I have used a timer strategy to overcome the default program to turn left when the robot reaches this barrier point at the given time. Also, when there are broken lines or no lines to detect, I have programmed the robot to move forward. This has helped me to provide a shortcut at this junction. I want to solve real-life problems using robotics and AI in the future, like helping elderly find their things using a heat sensor, as they always tend to lose things. I want to become a software engineer and help the world and my community. Hope you all enjoyed my presentation. Your comments are welcome. I once again thank everyone for this opportunity. Thank you.
I'm a game changer. I'm a risk taker. I don't hide from the battle. The battle hides from me.
Hello, my name is Dong Kim. I live in South Korea, Anya. I am going to participate in RCAP CoSpace GrandPrix Challenge. U12. I've been learning robot engineering since I was 8 years old. When the grounds are all back, the car goes forward. Sometimes it does not work in the right way. That's the reason why I set a time to change the direction of the car. Also, there was a very hard part on a map. The car have to find a line and turn around, but I don't know how to find the line, so I put all the possibilities into my program. It was a little difficult. When I first practiced the CoSpace, it was like a game. As the time passed, it became more difficult because I had to program ultra sensor and color sensor too. However, I'm willing to learn more about the CoSpace. It's very exciting. Thank you for listening to my speech. Bye-bye. Part 1. When ultrasonic sensor sees obstacle, I program to swing turn to right. Part 2. Between 14 to 19 seconds, when floor is all black, I set to turn left. Part 3. I didn't program things, but it just go forward. Part 4. Between 25 to 28 seconds, I make it turn right. Part 5. I made the car to go straight between 30 to 33 seconds because when I didn't program it, it didn't go where I want. Part 6. Between 34 to 37 seconds, when ultrasonic sensor sees obstacle, I set to turn right. Part 7. Between 40 to 43 seconds, when ultrasonic sensor sees something, I make it to turn right. I don't know why I have to keep turning right when ultrasonic sensor sees obstacle. Part 8. Between 56 to 60 seconds, when ultrasonic sensor sees something, I set to turn right. This part is the last part of the ultrasonic sensor using. Part 9. In this fork, I really didn't program anything. I am not telling a lie, it just go right. Part 10. Also no program. It's so a line and trace it. Part 11. This was so much hard I put all of my effort in this part. So I set to turn between 77 to 81 seconds, but it didn't work, so I fixed it by programming all the number of cases on it. Part 12. Last, I programmed to turn when floor is all black between 96 to 98 seconds.
And we're off! The robot has left the starting point. Oops! And we have passed our first waypoint. Second waypoint. Awesome! Great turn! Keep going! Wonderful path planning! Awesome! Great turn! Keep going! Third waypoint. We are now halfway done. Keep going! Wonderful path planning! Awesome! Great turn! Fourth waypoint. Great shortcut! Keep going! Fifth waypoint. Keep going! Oops! Ninth safe! Last waypoint, almost there. And we have crossed the finish line. Congratulations, challenge completed.
Like to view more sharing videos? Visit RCAP Academy YouTube channel.